Hello and welcome back. Let's continue looking at logarithms and exponentials. So here we have something a little bit strange. We have some things being added together. We have e to the 2x plus e to the x is equal to 1. And when we stare at this, there's no way to turn e to the 2x plus e to the x into one exponential to be able to solve this. So this is something that when we look at this, this is a little bit suspicious. Now there's a trick, however, and this is a very useful trick that we'll see in several variations throughout the semester. When we look at e to the 2x, this is going to be the same thing as e to the x squared, because when we raise exponents to exponents, we end up multiplying them. And then we've got e to the x, and I'm going to move the minus 1 to this side. And now I've got e to the x squared plus e to the x minus 1 is equal to 0. This is something that we can actually solve because we can do the following. We can replace e to the x with u, and u is going to represent this variable. U is just going to represent e to the x. So what we have is u squared plus u minus 1 is equal to 0. Whenever we make a substitution, we have to be a little bit careful. So at the end of this, I'm going to check to make sure that everything is good to go. So here we've got u squared plus u minus 1 is equal to 0. And this is just a quadratic equation. We can solve this for u. So I'm going to use the quadratic formula. This is going to be negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And as we look at this, this doesn't simplify all that nicely. 1 minus, so this is 4 times 1 times negative 1. So this is going to be 1 plus 4. So negative 1 plus or minus the square root of 5 over 2. So we've got two solutions. We've got negative 1 plus the square root of 5 over 2 and negative 1 minus the square root of 5 over 2. And what I'm going to do is I'm going to plug these into a calculator so that we can see exactly what these are. So we'll have, I want to put this in parentheses, negative 1 plus the square root of 5, divided by 2. And this is going to be so I'll just round to three places, 0.618. This is going to be about equal to 0.618, or we'll do the same thing. We'll have, let's see, negative 1 minus the square root of 5 divided by 2. That's going to equal negative 1.618. And this is what e to the x is meant to be. So e to the x is going to be either 0.618 or negative 1.618. And this should be ringing some alarm bells because e to the x, an exponential, can never be negative. So one of our solutions isn't going to work. So this is why we have to check. Whenever we make a substitution like this, we always have to check to make sure that our solutions are going to work. So that was the minus one right there. So the only thing that we can have is the positive root of this quadratic. So coming back, we know that e to the x has to be equal to negative 1 plus the square root of 5 over 2. and this is the only solution that we have. And again, I want to know what x is, but this right here is going to be a little bit simpler. I can take the natural log of both sides, and we'll get that x is the natural log of -1 plus the square root of 5 over 2. And again, this is something that we could plug into a calculator to come up with an actual value for, but this is going to be the exact answer. Cool. So we had some addition pop up here that we couldn't really deal with, but we can deal with this when we are adding and subtracting logarithms, and this is quite handy. It doesn't matter what the base is, but if we add two logarithms with the same base, we multiply their insides. So log base b of x plus log base b of y is log base b of x times y. On the other side, if we subtract, we'll get log base b of x minus log base b of y. This turns into division. We'll have log base b of x minus y. So let's put these to use, and let's combine some logarithms into one. So first of all, we've got 2 log base b of x plus log base b of 3x plus 1 minus 4 times log base b of 5x minus 1. What we'll notice first is that we've got some coefficients out here. Coefficients are going to cause problems because nothing up here has coefficients. So what we need to do first is get rid of all the coefficients. And luckily, we have the power rule, which said that when we have an exponent, it comes down front to just multiply the logarithm. Well, we can do this in reverse. So 2 log base b of x is the same thing as log base b of x squared. This one doesn't have a coefficient, so we'll just leave that there. And then this one, I'm going to move the 4 back up as an exponent. So it's going to be log base b of 5x minus 1 to the 4th power. So far, so good. And then now I get to combine all these. So again, we're adding these logarithms, so we get to multiply what's inside of them. And then we're subtracting the last one, so we will divide by that last one. This is going to be the log base b of, so we've got x squared times 3x plus 1 all over 5x minus 1 to the 4th power. This is just a gigantic logarithm, but it's something that we could deal with, and we've turned it into one logarithm. So let's look at this. What am I trying to say? This equation right here. So we've got log base 5 of x squared is equal to log base 5 of x. And there are multiple ways of doing this one. And I want to show you multiple ways to get this. So first of all, if we have log base 5 of x squared is equal to log base 5 of x, it stands to reason that x squared should be equal to x. So one way to do this would be to undo the logarithms and get exactly what I just said. So in the same way that logarithms undo exponentials, exponentials undo logarithms. So if I take both sides, I write 5 raised to both sides, so 5 raised to the log base 5 of x squared, and 5 raised to the log base 5 of x, I will get x squared is equal to x. And we can solve this, and we get that x is going to be equal to either 0 or 1. And right away, there is a problem with one of these. And again, it's important to check your solutions. If we plug in 1, so again, log base 5 of 1 is always 0. Log base anything of 1 is 0, since anything to the 0 power is going to be 1. However, log base 5 of 0 does not exist. And in fact, we can say that the log base anything of 0 does not exist, because if I'm searching for something where I take b to the y power and I get 0, I can't do it. If I take b to any power, I have to get a positive number. So b to the y can never be equal to 0. This one is not a solution, and my only solution is 1. But there are other ways to do this. There are other ways to solve this guy. So let's look at one of them. Maybe I need a little bit more space. So I could take my original equation and move it over to the other side. So I can have log base 5 of x squared, and I'll move this to the other side, minus log base 5 of x, and that should be equal to 0. When I subtract these guys, I'm actually dividing, so it's going to be the log base 5 of x squared divided by x. Well, we can simplify that right away. X squared divided by x, that's just x, is equal to 0. And oh hey, look, this means we can rewrite this equation as 5 to the 0 power should be equal to x, or x is equal to 1. And again, this just comes from the fact that logarithms and exponentials are essentially inverses of one another. So 5 to the 0 power is equal to x. So here we didn't even get this extraneous solution 0. We only got the correct one, which is pretty nice. So let's do another example here. So we've got the natural log of 3x plus 1 minus the natural log of 2x is equal to 1. So when we subtract these guys, we will get the natural log of 3x plus 1 divided by x plus 2. Again, because we're subtracting, we will divide these guys, and this is equal to 1. And so remember that the natural log is going to be log base e. So what I can do is I can take e raised to both sides, and logs and so e raising e to a power to a natural log will cause these guys to cancel out. So we've got 3x plus 1 divided by x plus 2 is equal to e to the first power, which just happens to be e. And then this is something that we can solve. Maybe I'll go through the steps fairly quickly. Let's multiply both sides by x plus 2. It's going to be equal to e times x plus 2. I will distribute the e, so let's continue up here. So we've got 3x plus 1 is equal to ex plus 2 times e. And I need to solve for x, so let's move this to the other side. Minus ex is equal to 2 times e minus 1. And then when I pull x out and divide by the 3 minus e, I'll get 2e minus 1 is equal, divided by 3 minus e. Cool. And again, we want to check to make sure that this works. So the one thing that we want to check with a natural log, with logarithms, is that we can only plug positive numbers into a logarithm. And there's a reason for this. So if we remember that if we take a power, this must always be positive. So the range of an exponential, I'm running out of room up here, is always going to be from 0 to infinity. So we can only get positive numbers from an exponential. And since logarithms are the inverse of an exponential, we can only plug into a logarithm what we can get out in an exponential. So the domain of a logarithm is going to be from 0 to infinity. So this is in fact a positive number. So we are good to go. We can plug this into our logarithm.